So I'll start the thing with the usual reminder that it's a 5-series webinar and that we have tackled an introductory webinar on digital technology in the first week. A month ago, dealt with bursts and leaks on the second webinar 2 weeks ago, and now we're dealing with commercial loss management. Can I share now? Yes. Okay. Is it happening? What is shown? Is it shown? This one. Okay. I was wondering whether you saw this or the cake that I plan to bake after this.
Cake also.
Okay. So after that, maybe I can share the cake recipe. Okay, we have 62 in the room. We shall open in a few seconds. Now, open. Okay. Good afternoon, everyone. Let's just give a minute or so to allow more people to participate. Okay. Okay. Good morning, everyone, and welcome to the third installment of our 5-series webinar on digital transformation in Asia's water and sanitation utilities. Recall that about a month ago, we had first introductory webinar on this topic, and 2 weeks ago, we focused on leaks and bursts. Today, we are focusing on commercial loss management, and we have with us two experts that will share their experiences on this, but they will be introduced shortly. Just to remind all of you that our next webinar will be 2 weeks from now, and we hope that you will also join us then. As with the past, just a quick reminder of how we can interact with you. We have muted all of you because there are quite a number of people that are participating now. For all questions that you have, please look at the green arrow and type in all your questions for the speakers in that box. There's also a chat box and all concerns on logistics, audio, video. If there's an issue for Waterlinks, please also use the chat box for that purpose. For today, we have our first speaker. You will see this is Delph Mac from Xylem. I'll introduce later. Our second speaker is Sandeep Mahajan, Head of IoT and GIS for Suez India. And of course, Arjun will do his summary, which he does at every webinar. Oh, sorry, but before we get into that, let's start with a poll, just to understand who are the people with us now. There are several questions, so please scroll down. We asked you to participate in this poll. We're giving you maybe a minute and a half to do so. Please kindly respond to the poll that you can see on your screen now. Okay, you're not responding. Please respond. Okay, 1. Thank you. Just to remind you that there are 5 questions, so kindly scroll down for the rest of the questions. We currently have 86 participants that are with us this afternoon. Thank you for your time. Okay, I'm ending the poll now. More or less, we have mostly male participants, and age would be mostly in the 40s and 50s. Sector would be water utilities, both in the private sector as well as in the public sector. Most of the participants now are in the public sector. And a lot of technical staff are with us today. 43% of you are from the technical field, have a technical background. And most of you wish to understand what digital transformation in urban water supply and sanitation operations mean. All right, so without further ado, I would like to now proceed with the introduction to our first speaker. Our first speaker is Delph Mack. So we have a gender balance in today's seminar. She is Regional Director for Xylem Digital Solutions based out of Singapore. She finished her chemical engineering from the National University of Singapore and an MSc in engineering and management from MIT. Prior to Xylem, she was also with Deloitte Consulting. She's worked a lot in various roles in several sectors and several industries, water and energy included. But for now, her main focus is really trying to accelerate growth in Asia for the solutions that Xylem has developed in this market, for this market. So please, Delph, floor is yours.
Hi everyone, thanks Mai, thanks for inviting me to this webinar, and thanks for the great introduction. So as Mai mentioned, my name is Delph Mack. I'm Regional Director of Xylem View Digital Solutions, and I'm based in Singapore. Today's presentation, I'm going to bring you through the data-driven approach to reduce apparent losses. So let me share my screen. Okay, Mai, I believe you can see my screen now.
Yes, indeed.
All right.
Proceed.
I will tell the story of how we bring the solution from America to Asia. Before that, let us look at what is apparent loss and what are challenges it presents from apparent loss. Basically, to kind of like bring everyone to the same stage of understanding about apparent losses. It's the same as commercial losses. They are basically water that is consumed but not billed to the customer. And as a result, it causes impact to financial sustainability of the water utility. It also causes about an average of 2% of top line revenue being lost annually through these apparent losses issues. If you look at this chart below, there is the IWA water balance table. It is very commonly used in water industry. It shows us the water balance. So the last few sessions, you might have already heard about this water balance table, where we use it to identify the amount of water that we bill to customer here. Sometimes water is used, but it's not billed, but it's still authorized because it's used for purposes like firefighting. And for the last few weeks of webinars, we have been talking about water losses. The 2 weeks ago, we spoke about real losses, on how leakages and bursts result in water that's lost through pipe networks. And today we are talking about apparent losses, which, as I mentioned, are water that's consumed but not billed because of these three reasons. One is unauthorized consumption. Second is customer metering inaccuracies. And third is data handling errors. And for today's purpose, I will focus more on the customer metering inaccuracies, which we can solve with a digital solution called Hidden Revenue Locator. The key problem that Hidden Revenue Locator is trying to solve is the information disconnect. So it's basic terms, there are thousands of meters, millions of meters sometimes in a water system. How do we know which meters are underperforming, which ones are losing revenue, and how do we keep track of all these millions of meters across the entire fleet? We want utility to rethink their meter asset management strategy. So looking at the left box, this is what currently a lot of utilities are doing, the status quo state. They adopt typical strategies. For example, number one, meter replacement based on age. However, from our numerous studies, we find that age is not a very good indicator of poor performance of meters, which I will tell you more in details later. The second method that a utility uses is randomly bench testing a small number of meters and making assumptions and driving your meter replacement strategies based on these assumptions. So again, like these assumptions can be misleading. It can lead to leaving good meters in the ground. It can lead to replacing good meters and leaving the underperforming meters in the ground. The third strategy is basically no strategy, it's just replacing meters when everything fails. So that is really a reactive approach. It's not what we should be, it's not a strategy that we should be adopting. So we want utilities to think about how we can use data-driven approach to change this entire methodology of replacing meters. How can data-driven approach help us? So firstly, we can replace meters that is based on each individual's meter's performance. We want utilities to redesign their budgeting strategy such that it can be guided by the number of inaccurate meters in the system and the expected payback if you replace that particular meter that's not working well. Utilities themselves also want to have a trackable and quantifiable impact on apparent loss reduction. And in the next few slides, I'll talk about how can we deploy this data-driven approach. The solution is called Hidden Revenue Locator. It is a data-powered approach to proactively manage meters and help utilities to identify meter inaccuracies and optimize revenue. Number one, it helps to quantify the loss, apparent loss for prioritization, meter by meter. Number two, it locates the meter errors, errors such as under registration, meter read errors, and meter sizing errors. Number three, typically we find that we can locate issues up to 5% of the entire meter fleet. This allows us to recover 1.5% of top line revenue annually. And last one, with this solution, we want to help utilities to proactively manage their revenue and improve their operational efficiency. This solution leverages on machine learning, AI, as well as industry intelligence, which I will go through more in depth in the next few slides. And I'll use a case study to tell you the story of how we implement the solution, the challenges we face, and the insights that we find. This particular case study is on Clayton County Water Authority, which is a small-sized utility in America. This utility provides water, sewer, and stormwater services. They have about 85,000 meters, and most of the meters are mechanical meters, out of which about 2,500 are commercial large-size meters. They read meters every month, through automated meter readings. That is to say that you can have like drive-by to take readings through a device that allows you to transmit the data through a short distance. This utility also collects about $110 million in revenue every year, spending $24 million on CAPEX. Their challenges are the following: that they typically use a reactive top-down water audits. They have challenges managing the large amount of data coming through from the AMR readings, which is coming through every month. They needed a timely and trusted data insights to understand what they should do next to provide decision support for their actions. And they don't really have a structured meter replacement program. So they want to have the goals of the following. Number one is that they want to manage the 2,500 commercial meters in a more structured manner. They want to recover revenue from the underperforming meters. And they also want to use advanced technologies to help them improve their operational efficiency. This is how they have done things in the past before they start adopting Hidden Revenue Locator. What they did is that they will do a random testing and replacement method. They send trucks out to randomly select 100 large meters and test them. And while they're testing this, they find that only 5 meters would fail the test and only 5 meters need to be replaced. However, this method really provides them with minimal benefits because they're just randomly randomly going out to test the meters and replacing only a small percentage, 5 to 6% of these meters. And they just keep on doing this every day, every year. So the result is incurring cost of these 100 truck rolls, which is sending out trucks to do the testing on sites and doing the test and replacement, which gives them very minimal benefits. What they want to do is to proactively manage these apparent losses to reap the following benefits: to improve their revenue assurance, to reduce apparent loss, to improve their CAPEX planning, and to be better in operational efficiency. They have an ongoing subscription contract with us to use Hidden Revenue Locator. They have done this since 2016, went through several phases of these projects, and now they are concentrating on large meters. In the next few slides, I'll go into details of how Hidden Revenue Locator have helped them to find these water meter anomalies, and a little bit of detail on how this algorithm actually works. So there are 3 types of water anomalies that we identify typically. The first type is water meter under registration, which means that these meters are recording less water than the actual water flow flowing through the meter. So because you are recording less water than the actual flow, you are receiving less revenue than what you're supposed to. The second type is water meter read errors. The meters detect negative reads. It detects consecutive zeros that is not supposed to do so. Based on trend analysis, we will understand that these consecutive zeros are not supposed to happen. It's out of the norm. And the third type of error is implausible reads, which means that the reads are technically not achievable by that meter, and we do not know why it's giving us those reads. Then the third type of water meter anomaly is meter sizing errors. So the meter can be too large or too small. So if the meter is sized too large, there could be small amount of water that is flowing through the meter, but the meter is unable to record the small amount of water. If the meter is too small, then it could be under recording. There could be a larger flow through the meter, but the meter is recording less than what it should be recording. These are the common types of anomalies that we find through our Hidden Revenue Locator. And water meter under registration is the most common one. And I will touch a bit more on details of this particular error. Our algorithm analyzes water meter under registration, considering 4 factors here. The first factor is on analyzing the under registration factors. Age is not a good correlator, but is still a factor that contributes to under registration. We also consider things like how much water is flowing through, the water quality, etc. The second factor that we consider when we do our analysis is the environment that this water meter is in, whether there are weather patterns, whether there are conservation efforts that is causing that anomaly. Maybe it's not that the meter is actually having a degradation, but it's just because of weather or conservation efforts. And then the third one is to filter out the expected short-term changes such as in occupancy that could have affected the water consumption. With this, we find that our method allows 6 times more effective, is able to give us 6 times more effective results to identify these underperforming meters compared to the status quo method, the random testing method that I mentioned earlier. Okay, more in depth into this meter under registration algorithm. Earlier I mentioned that okay, this is a meter read volume. It's a monthly read, and you can see that this line is a downward trending line. It potentially could mean a degrading water meter. So the blue line is how we adjust it based on what we call community effect. So we normalize the meter read according to the trends of the community, which could be affected by weather patterns, seasonality patterns, and certain issues like conservation efforts. Then we have a predicted trend that is about based on the past historical data. So this black trend line is telling us that if the meter is working 100%, perfectly fine, how much water it should be consuming. So taking the predicted minusing off the skilled volume, we have the revenue loss shaded in red. So the meter should be recording at this predicted line, but the actual read is at the blue line. So whatever that is the difference is the revenue that's lost. Okay, in the next few slides, I will come out to the broader picture of how the dashboards looks like and the insights that you can get from these dashboards. Over here, you can see that the top few boxes give you the critical metrics of the entire fleet, metrics such as the total revenue lost to date, the total volume lost to date, and the ongoing issues. We can filter these issues based on several different types of parameters, such as the issue type, the customer type, meter size, or investigation status. So once you apply the filter, you have a list of issues that you have filtered over here in the center, which give you a lot more details by the specific meter itself. And then when you click into one of the meter, of course, it shows you the details of this particular meter. So for this case, it's a meter that is under registered. It tells you details such as the ID, the address, and as well as down to the details of how much money you lose because of this meter, how much volume you're losing because of this meter. And you can also pull out the dashboard that shows you a trend line that you can see that is potentially under registering meter. After you know about the issue of this particular meter, we also recommend the actions that you should take to investigate this case. So there will be an investigation window that you can pull out to follow through the actions. and this facilitates work orders. You can also add notes after you have done the work order or after you have done the investigation, and all these will be recorded as part of the investigation results. Other examples of the insights that we provide through this digital solution are these insights. For example, if you look at the left chart, you see that what I told you about how age is not a good parameter to determine meter performance. You can see that those are in the younger clusters. The orange ones are the meters that were analyzed. The blue ones are those with issues. And you can see that even though meters can be quite young here, there are still a lot of issues with these meters. And then the second insight from here is that when you want to replace meters by age, a lot of times you are replacing a lot of meters that are actually still functioning well. So let's say you look at a 10-year-old meters. So out of this meter size, about 3,000 meters that were analyzed, quite a lot of them are still functioning well. But if you do a meter replacement strategy by age, you end up replacing a lot of these meters that are functioning well, which is causing you a lot of money to do so. Then moving to the box on the right, the chart on the right, we also give you analysis based on the different meters type. So this one, you will see that on this chart, right, you'll focus more on the 2-inch meters, because the 2-inch meters is telling you that there's a lot of flats, like 400 plus of flats on the 2-inch meters, compared to the 1.5-inch and the 1-inch. And why we focus on this is because larger size meters typically allows you to have larger amount of revenue. But having like quite a lot of flats here is something to worry about. So this particular chart will drive your eyes towards 2-inch meters to go and investigate what's going on with these meters. And back to the case study of Clayton County, for the most recent results that we get from the commercial meters analysis, we have quite interesting insights from there. The first one was a revenue impact analysis that we did. Then we found that the revenue impact is quite substantial for commercial meters. So we look at 16, a total sample size of about 80 meters in total. And 16 large meters contribute 200,000 of revenue, incremental revenue gains, if we have not replaced this particular meter for the next 2 years. So this, what I'm saying is that these meters, right, they could be under registering, and if you don't replace them for the next 2 years, you wouldn't have gained 200,000 of revenue. But if you look at the smaller meters, right, even though there is a larger number of smaller meters, it contributes to less amount of revenue. This is because typically large meters, there's larger consumption going through the large meters, and therefore there'll be larger amount of revenue you can collect from the large meters. So this allows Clayton County to have a proactive action managing their commercial meters, and they continue to do that with Hidden Revenue Locator. The second insight from the recent case study that we did with Clayton was that we calculated the revenue loss of 30 flat meters. We investigated 2,500 of large meters, and we find that there were 94 flats, out of which 30 were tested and it was accurately flagged out. This is more accurate compared to the traditional method that Clayton County was doing by about 7 times. So the revenue loss from the start of the issue identification to current date, in total, it was about 600,000. And if these meters that are under registering, they are not replaced for another 2 years, they would have lost another 270,000. So this is another great insight we got from the recent analysis that we did with Clayton. Then coming to Asia, we have actually done several trials in the Asia market, Southeast Asia utilities, and we did quite a number of studies to see how we can bring this solution to this region. With every country and every region, there is its own set of challenges, but every challenge also allows us to turn it into opportunity. So the first challenge is the lower tariffs in Asia. It could be because of government subsidies. And with lower tariffs, this means that there will be a lower lower value of revenue recovery. What this means as opportunity is that the utilities here should really, like what Clayton County did, focus on commercial and industrial accounts which consume larger amounts of water, and the meters degrade faster because of the high usage. The second challenge in Asia context is that there are more meters with high degradation rate, perhaps cheaper meters with lower quality. And utilities in Asia are much bigger than American utilities. They tend to replace the meters in bulk after a certain number of years. This spells a new opportunity for utilities to have better CAPEX planning based on data-driven insights, replacing meters only when the meters are identified as underperforming, and having a better strategy that is more transparent. The third challenge is on less guidance from regulators. So over in Asia, they could be, compared to Europe, regulators might not be sitting down with you to go through your targets and making sure that you hit those targets and helping you to adopt good practices. So it is a chance for utilities to be water leaders themselves in this region, to develop good strategy by using data-driven approach. I will go into more details to show you the value illustration if we look at the first two opportunities. So opportunity one is based on an illustrative example from the trials that we did, as well as the studies that we did on Asian utilities. So the numbers here are kind of reflective of a typical Asian utility. This one is a mid-sized utility of 800,000 accounts. The total revenue that this utility will get is about 300 million. Commercial fleet size is 40,000, 5% of the total size. However, the commercial fleet revenue can amount to 120 million. So 5% of the fleet gives you 40% of total revenue. And this is because over here, there could be higher tariff for commercial use, and there could be higher consumption from the commercial meters. And we did some calculation. If we recover this revenue for about 1.5% with hidden revenue locator, the total revenue that we can recover for commercial usage is 1.8 million, and the one for domestic is 2.7. If you divide this by the number of meters, you get $45 of savings per meter for commercial and only 3.5 per meter for domestic. So this shows you the scale of how different it is, and helps you to focus on commercial meters that provide you with greater benefits. And the last example is on better CAPEX planning. With this, we have an example using a 1 million accounts fleet size. This particular utility replace meters every 8 years. Oh, sorry, replace meters of there's 8 years and above. So the meters that are aged of 8 years and above. Then the average number of meters that you are replacing will be about 225,000. This is translated to a CAPEX of 3 million. So we did a simple calculation. If we take an analysis based on 20,000 meters, and out of which 2,500 are more than 8 years old, the total number of anomalous meters that we have found with our hidden revenue locator is 410 anomalous meters. This means that in this particular year, when you replace all the meters that is 8 years old, 84% of those meters could be functioning well. You could have replaced them on the 9th year or on the 10th year. You don't necessarily need to replace it on the 8th year. So if you have adopted a data-driven approach to replace your meters, so let's say you cut down the meters replacement to 100,000 from 125,000, this difference would have helped you save or defer your CAPEX by 625,000 per year. So it's pretty substantial. And to wrap up my presentation, I will just summarize the value of a data-driven meter management approach. Firstly, you could have recover 1.5% of the top line revenue. And second, you can improve operational efficiency by having a more structured ways of identifying meters that are underperforming and prioritize a replacement strategy based on these meters that are underperforming. And third, on CAPEX planning, you can avoid unnecessary replacements of functioning meters and redesign a more optimal meter replacement strategy. So with that, I'll end my presentation.
Thank you very much, Delph. Very informative. You now have quite a number of questions, so let me just start with this. Does the hidden revenue locator require raw data from an AMR system, or can manual data readings be used to perform the analysis with the same level of success?
Yes, so we have a guideline of minimally it should be read once every 2 months. Manually is fine. AMR, AMI is also okay. But of course, if you have larger volume of data, you will get higher accuracy of insights from larger volume of data. So minimally once every 2 months.
Okay. And can the locator figure out the meter drift against sample meter calibration? I'm not sure. Yes, please.
We do look at the individual meters performance, and we can do sample calibration that relies on whether the sample is representative. So yes, we kind of need to take some sample to analyze to find out whether there is a drift.
Okay. What type of water meter would be efficient, and can you name a brand? I'm not sure if you should name a brand, but
what type of water meters will be efficient? I would say that like today, and maybe the next webinar will tell you more about the type of meters that are good. Today there's more a trend towards using static meters compared to mechanical meters. Basically, static meters has less moving parts and allows you to record water without having so much degradation. So it degrades at a much slower rate, and theoretically it can last for the longer lifespan. Yeah, static meters. And what brand? there are different types of brands, so I'm not sure whether we can name it.
Yeah,
but
so I think you leave it. Yeah, you leave it to the type of meter, and you have responded well. What happens if there is over-registration, and how does one address it?
Over-registration, I think that's a very interesting question.
Has that happened to you in your experience?
We don't really find that as an issue. So yeah, it's actually quite interesting. I will have to check that with our subject matter expert. Yeah, typically it's under registration.
There are 2 types of meters, a plastic and a brass type. Which would you recommend?
Plastic or brass type of meters?
Yeah.
Okay. I wouldn't have much comment on this. In the next webinar, they will have more insights about the meter
types of meters. Yes.
Yeah. So that question can be deferred to the next webinar.
Okay, we'll do that. Another one here. based on your I think this is more a comment, but I'll read it anyway. Based on your presentation, it would be safe to assume that any effort to start water supply / utilities in off-grid areas gives one a clean slate in supply management. And it seems it would be in our best interest to consider the application that you've discussed, ? Meaning an area with nothing, with no service at the moment and no system. Would your technology be appropriate for something like that?
Yes, it's definitely an interesting case that we can look at. And I'm sure we can find a solution to such a problem. We have applied a lot of our digital solutions to new projects. And definitely, I wouldn't say that there is any problem with looking at new projects and applying our digital solutions on any new projects.
Okay. And of course, your contact details have been sent as well to everyone. There's a question on whether Xylem provides its own software, meaning develops its own software, or you manage software, other software with common SCADA.
This particular solution I mentioned is by Xylem, is owned and designed, developed by Xylem. Some of our solutions, we acquire it through acquisitions, merger acquisitions, or we acquire the technology. But for this particular one and the few that was mentioned before in our webinars, they are all owned by Xylem now. We have collaborations with other vendors to provide other types of solutions. But those that we have mentioned in this webinar series is all by ourselves. Yeah.
Okay. All right. And a final one, how would you approach change if there was intermittent supply instead of continuous supply? Have you worked in such conditions? For example, in India, we have quite a number of Indian participants.
Yeah, I would say that there is definitely a challenge. Data availability or data gaps is a challenge to every single digital solution. But as much as possible, we will find solutions to, let's say, do interpolations to cover the data gaps. Or we allow machine learning to help us identify the patterns and to cover those gaps based on the pattern trend analysis that the machine learning is able to develop.
Okay. There are some other questions here, but I'll leave it to you to respond via chat if you can, because we need now to proceed to the next speaker. So thank you very much, Delph.
Thank you.
For your presentation.
Thank you.
Okay, so thank you. I would like now to present our next speaker. Our next speaker is from India. He is Sandeep Mahajan, who is the head, he's the head of GIS and IoTs for Suez, India. He has a PhD in Water Resources Management from SRM University, Chennai, an MTech on Remote Sensing from the Birla Institute of Technology in Ranchi, and an MSc in Geography from the Kurukshetra University. Okay, and Sandeep now is working with Suez, India, and Suez has quite a number of projects there. But previous to that, he also did a lot of work still in the same sector, in the same field of GIS and R&D. He worked with Columbia University on remote sensing and GIS that benefited quite a number of farmers in India, in Gujarat and Punjab states. He was previously also working for RMSI Private Limited, which also has various water utility and sewerage projects in India. He has worked as well in several infrastructure projects funded by the ADB, World Bank, JICA, and the like. So please, Sandeep, it's a perfect opportunity now after the discussion of Delph about how to introduce these technologies into Asia. And we're now wanting to hear exactly how you are doing this in India.
Thank you,
So,
Mai. Thank you very much.
thank you.
And thank you for giving us this opportunity to present and share our experiences. May I share my screen?
Go ahead.
It's showing that only host can share.
Not allowed. Not allowed. Try again.
Okay. Yeah, now it's okay.
Okay.
Thank you. So is that visible, my screen?
Yes, it is.
Okay. So as explained by Delph, that means yes, these metering and digital tools and technology is very important. So today I'm going to discuss about digital transformation in water and sanitation utility, basically in Suez, India. So this is the presentation outline. First, I will briefly explain means our presence globally as well as in India. Then what are the commercial losses? Then ropes. Ropes is a digital tool which we developed in India in 2013, and we successfully implemented this tool in water and sewage utility across India. Then digital transformation journey in India, examples of digital data as well as applications. Then case study of one of the South Indian city, Coimbatore. And then why digital data is important. So these are the few footprints of Suez in water, waste, and in both. So you can see, means we are covering entire globe with our projects. And these are the few locations for India where we are working for water treatment plants, means in the all big metro cities, Suez built their water treatment plant, and then we are managing the water utilities in almost 12 cities. So this is about commercial losses. So I would not explain in detail, as Delph is already explained all these commercial losses. So briefly, I will say there are two types of commercial losses. One is customer loss, which is related to non-measured and unbilled use. And second is billed data error. And the second one is metering losses, which is related to non-authorized use and under metering. And these are the three major types of water meter error. Okay, so then water theft and unknown consumption. So now I would like to explain about ropes. So ropes is a real-time operation performance system. So we gave this technology a name, ropes. Okay, which basically works on four principles. One, and if I just divide it into four steps. So in first step, we are collecting the requirement from the client or from internal teams. I mean, what kind of information they required to perform their operational activities, and what kind of data they require to perform these activities in efficient manner. So first we are collecting that information and we are converting that information in digital forms, which forms can be used through mobile phones as well as tablets. Then step two is we are providing training to our field staff to how to use these tools and technology, and how to collect that information from ground, and how to deal with the local participants and other stakeholders. Then after finalizing these forms, we are just uploading these forms to the cloud server, and our field crew can download these forms and they can fill the information as per the form, and they can send back this information to the cloud server back. So this is a two-way data information sharing technology. Means our field crew can send that information, but on the same time, as soon as on the server we are receiving this information, we can assess that information and we can say, okay, that information is sufficient, or they have to revisit, or they have to rectify that information. And once that information is finalized, quality is checked, then we are putting back this information in final databases. So this is about the ropes technology and how that works. So this slide will explain means about digital transformation in Suez, India since 2013. So let me explain a little bit about the background, means why we developed this tool and technology, what was the requirement. So in our very first project in India in 2013, so whatever data we received from the client side, that data was not sufficient to perform our activities. So initially we made our designs and all based on that data. But when we start our execution on the ground, the data in the system and data on the ground was very different. So that's why at that point of time we realize, okay, we have to validate as well as we have to recreate the data for our requirement, because we have to manage this system. So ropes basically is working on 4 principles. First, to collect the information, then assess that information, then publish that information on web, and then various departments are taking action on that particular information. And entire system, entire ropes application is working through servers, mobile applications, web applications, then interfaces between various servers and tools and technology. And entire thing is based on centralized platform. So all things are placed at a centralized platform. And not only single department, so entire departments are linked with this centralized platform, and under ropes umbrella we are developing application for all the departments, like for legal, for CS, customer services, for IT, health and safety, finance. So all the departments, whatever their requirements are to perform, to enhance the efficiency of the performance, so we are developing these applications. And yes, this is a tested solution which we implemented in more than 12 cities in India. We delivered more than 30 digital solutions across various departments of Suez, India. And we collected more than 6 million consumers information, which are digitally mapped in GIS, and more than 10 million water meters were digitalized and were readed through these mobile applications. So that I will explain in the next few slides. So more than 6,000 kilometer underground water network were also mapped in GIS by using these tools and technologies. And apart from network, more than 8 million assets we also digitalized. This also I will explain in detail in the next few slides. So these are few data submissions, digital data submission on the server of few projects of India. So these are the locations of Indian projects. So you can see this on the top in New Delhi, where I'm sitting. This is our development center, and all sort of tools, technologies are developing here. So our core team are sitting here. And then we have a excellence center in Bangalore, where all these tools and technologies are validated and implemented on various locations in India. So we have a dedicated GIS and IoT team at all the project locations as per the project size and the requirement. Okay, so let's discuss, as I mentioned, means the background. So you can see in this image, the red lines were the data which we received in 2013 when we started our first project. So this is a part of area, means part of the project area. So these red line we received from the client, but when we actually survey on the ground, when we found, okay, these gray lines are the actual field condition. So you can see the gap between input from client and actual ground reality. Okay, so then we started our activities. We developed in-house tool and technology with our internal team. And then this is the example of how we started our activity. First, we acquire the satellite images, high resolution satellite images, and over the images, we just demarcated the project area, and then all the building parcels and consumers which belongs to that project and that utility. So this slide explain means in what depth we are collecting that information, because we have two particular activities in water utility and sewage utility projects. First, we have to rehabilitate the system, entire utility, including assets, including customer database, network, all these things. And then second part, we have to provide new infrastructure wherever water network or sewage network is not existing or is not sufficient to provide the services. So these are the few details means which we collecting in each and every project. So you can see the building parcels with the consumer house numbers, then streets with the trees, because this is also very important when we are designing a new pipe. We cannot cut the trees due to various environmental reasons. So our designer can plan in the GIS itself, okay, on which side of road they can put a new pipe. So this is a example of consumer survey activity. So how that data look like. So when we digitalize all the consumer information through satellite image mapping and through our field surveys, so we integrated all the information. So there are two examples. One is for residential and another is for commercial. So in this, I don't know it's visible to you or not. So we are collecting information regarding consumer name, consumer, whether it's metered consumer or unmetered consumer, what is their consumption, if there is any historical record. So all this information, first we are creating a base and then we keep on updating this information during the project. So this is small example of how we are collecting that information. So this is example of consumer property parcel mapping. So first we are plotting all the property parcels or household parcels. Our teams are going in the field. They are collecting information based on that GIS data. So then we are assigning a unique ID to each and every parcel. And this unique ID is a base for future activities in various departments, like customer service department is using that consumer ID for referring any historical data or asking any help from GIS and IoT department. Then property type classification. So this is something which we are doing in the beginning itself. So we are defining in our area how much properties are belongs to residential category, how much properties are belongs to industrial and commercial activities, because their consumption pattern is very different from each other. So then this is example of how our field crew is going in the field, and they are starting their survey activity with the digital tools, with the help of tablets. They are collecting information from the consumers, and then from the field itself, they are sending this information back to the server. So slowly and gradually, we are geo-coordinating all the building parcels and all the consumers of our project area, which not only helping us in operation, but also helping us in designing the entire system. So all in various projects, like in water and sewage project, the requirement of this information is different project to project. Like few areas where we got some information from client, so we are using that information and we are validating that information in on ground, and then we are creating our forms. We are capturing this consumer information, allocating unique IDs, then all the survey we are using through mobile application on Android platform. So whatever information we are collecting from ground regarding consumers, so that we are integrating into the GIS, which we are publishing on the web also for the easy access for the other teams, all other departments. which is very helpful in estimating the population as well as the total demand in that area. So like there, I'm taking one example of Delhi project where the contractual requirement is 150 LPCD per consumer per day. So we calculated the demand of that area. Okay, so in the next slide, I will show you means what information we got from client, and after survey, what was the surprises. So this is the example of a urban slum. So not only the developed area, we also have few pockets of undeveloped area where building parcels and building properties and consumers are not in very structured manner. So we are mapping these consumers also. And here I'm giving the example of another way of classification where we are taking information during our customer survey activity regarding whether that particular property is owned by a owner or who himself is residing in that, or it's a rented property, whether it's a public park or anything else. So why we are capturing this information? Because like during this pandemic, during this COVID time, the consumption pattern was fluctuating because the local resident are staying in their home, but the rented population, most of the population is migrated to their hometowns. So that consumption goes down. So if we have that kind of information in our data, so we can plan our activities, our distribution system very well. These are the points which are showing the access point to that property, which helps our operation and management team as well as our meter readers to from which side they can go to that approach to that particular consumer. So yeah, this is the example, a comparison between data what we received and what was the actual ground reality. So when we received the data, the total consumers, they said only 98 in the same area which I shown you in the previous slide, that urban slum area. But when we surveyed that area, the total consumer was 234 and the population is just doubled. Okay, there was no property classification, there was no building parcels in that data. So entire data we developed in 2014, and till date we are using that data, we are updating that information in very efficient manner. These are the few examples. So whatever I shown in that image, so that belongs to this project. This is a Delhi, part of Delhi area, South Delhi area. And this is another example of where we digitalize all the assets as well as consumers. It's a Kolkata city, eastern part of India. Then now, okay, data is one thing, but how we are using that data digitally and how we are updating that data time to time, that is very important. So these are few digital tools which you can see. One is consumer survey and mapping application, which is developed in-house and to collect information regarding consumer population, consumer means location, where they are locating, their property type, their consumption, which I mentioned in my previous slides. Then once that data is built, so that time we can develop this information into customer service management system. So we have in-house web application also where we are developing these consumers CSMS applications. Okay, so this is example of another application, which is meter reading application. So we have in-house mobile application for meter reading. So there is a small demo video which I'm not, time is not allowing me to present this fully, but I will show you a few glimpses of this video. Screen. So you can see means how a person can log in that video with their login credential. Then they can collect the information regarding the meter. Then they can collect information regarding the meter. They can capture the meter photo also. So let me show you. They can download the data from the server for the previous meter reading and history about that meter readings. And here I will show you the example of how they are capturing the image of meter. Here. So they can verify in the back office, okay, whatever reading is collected by a field staff, whether that is true or wrong.
This is mobile.
Then this is another example of asset data digitalization. Apart from consumer, we are digitalizing all the network. Our field crew are collecting that information, and we are managing that information through web interfaces. There is separate web applications also. And this is again a demonstration video for
Click icon to open app.
that mobile application. Okay, so I don't think that time allowing me to present this fully. Then this is a small example of asset digitalization and base mapping. Okay, so means whatever information we are collecting digitally, we are keeping that on the servers. Anytime, anywhere, anybody can access that information with the login ID credential. They can see, okay, what kind of information is there. Whenever we are exposing a pipe, we are making sure that information should capture digitally. Then once we are capturing all the information digitally, these are the few examples of plants, pumping stations. We are putting a QR code on each and every asset, which can be accessed through a mobile application after completing that survey activity, and they can update information about that, about the performance of that particular asset, about the other infrastructure developments. So these are few example of asset reports. And this is the final video of Coimbatore city, which will explain means how we are using this. This is just 1 minute video.
Implementation of 24/7 water supply system in the city of Coimbatore. User-specific login and intervention. Mobile-based application for reporting operations and works activities. Pocket DMOI's water supply status monitoring. Works intervention such as pipe laying, house service connection and leak repairing, etc. Real-time monitoring and GIS mapping. All the activities and intervention can be monitored on the real-time base, through web anytime, anywhere.
Okay, so this is my final slide. So I would like to conclude with this. Like we are going to a doctor for diagnosis. If we have a good report, doctor can give us a good treatment. He can advise us a good treatment. Same way, if we have a good information, good data about our utility, we can manage it very well. So this is an example of with GIS and IoT, with digital tools and technology and data, and without. So if we have that tools and technology, yes, it's very easy to locate the location. It's very easy to to streamline the process. There is no duplicacy. Online, we can transfer the data and all. That's it. Thank you.
Thank you. Thank you very much, Sandeep. I have a few questions here. The main event of your presentation are things that you have done in India specifically. And of course, data is knowledge. Having knowledge is power, effectively, for you to be able to manage your systems better. The question would be, does every household have a separate connection to the distribution line in the examples that you mentioned?
Sorry, your question is? Just a minute.
Okay, I lost it. I lost that question. So what? Is it clustered meters or are group? What if it is a clustered meter or a group of meters in one stub out? How can we put it in the GIS?
So that depends on if it's a if it's a bulk consumer, like if it's an apartment having only one bulk meter with a lot of resident in that, so then we are capturing only a bulk meter. But if it's a multiple residents are residing there with their separate meters, so we are capturing all the meters with the household.
Okay, and that's not an issue even if you have multiple meters in one location?
No, there is no issue.
Okay. Okay. And how do you entertain new applications with this GIS?
What does that mean?
So if there is a new a new customer, completely new customer, what do you do to his application? How does it get captured on the GIS?
Okay, so whenever there is a new customer in the database, so we are capturing that information whether through the application or directly to the web. As I mentioned, we are using that high resolution satellite images, and once our base data is created and we know, okay, in which locality or next to which property and which landmark that house is, so we are directly capturing in our GIS data. But yes, we are again validating that information whenever our field crew like meter reader or our operation and management staff is visiting that particular consumer.
So the other question earlier is whether every household has a separate connection to the distribution line in the examples that you provided.
Yes. Most of the consumers are having their separate connection, okay, apart from the bulk consumer.
Can GIS determine pressure line like EPANET?
No, GIS cannot determine the pressure like EPANET, but we are putting some sensors under IoTs, okay, which can link directly with the GIS data. In the city of Bangalore, we did that exercise and we link all these application with the GIS, and on the real-time basis, we can see on the map, okay, what is the pressure logger information of that area.
Okay, and okay, so I don't have any other question here unless there are other questions. This is now the time to ask. But for me, I just want to emphasize, I think it's in relation to the previous question. Obviously, GIS is not a static set of data. One must regularly update it. So how often does one have to update this?
On the monthly basis, we are releasing, we are changing, as I mentioned, means everything is on web-based. So every month, this is our journal practice. Every month we are updating information on that web portal. So if we are giving GIS information in a mobile application, we are making sure that information will expire within a month. And then they are again asking, if they require, then they are again asking for a new API or a application for that particular GIS data.
Okay. How then can we decide on additional connections if there is no pressure involved? I guess this is in relation to the question on EPANET.
Yes. So see, that is, as I mentioned, means it's an interlinked activity. So we are using a common integrated platform where we are getting information. So first we are creating a base in GIS. Then if our base is strong, then whatever information we are getting, whether from O&M department or customer service department or any IoT device, so we are calculating that information. We can estimate that information and we can provide the new connections or upgrade in the connection, all these things.
Okay. Thank you. Thank you very much. Oh, I still have some
Thank
more
you.
questions coming in. No, I think, I'm not sure if this question is for you or for Delph, but either of you. One is, I am still confused, he says, is there use for a mechanical meter and reading by a meter reader manually, then uploaded to Android for digitalization, or each meter with cable and becomes automatically ready time to time?
So in
Would that be a
our
proper
project
question for you,
area,
Sandeep?
yeah, means in our project area, there are multiple kind of meters. Okay, so there are mechanical meters as well as there are AMR ready meters also, not fully AMR. Okay, so in both the cases, like in mechanical meter, yes, our meter readers are going in the field, they are collecting that information from the field manually through these mobile application which I just shown. They are capturing the photograph of the meter every month or whatever, whenever that meter reading cycle is coming, and whatever AMR
So
they are.
essentially you're using both. You're using both AMR and mechanical meters.
Yes,
And for the
yes.
mechanical meters, that's where you need the meter reader app, reading app.
Right. So I can give example like in Delhi was our first project which we started in 2012, and so that time all meters are mechanical meter, and our recent one is Mangalore project where we are going to implement, Mangalore and Coimbatore, where we are going to implement these kind of advanced meter.
Which GIS platform are you using?
ESRI, ESRI platform we are using. This is a standard for Swiss.
Okay. You also showed quite a number of people doing the work. How many GIS personnel does one need in a project?
That
Do you
purely
have a large
depends.
number of GIS?
Yeah, means that in the initial stage, when you require a lot of information from the ground and you have to capture that information into the system, that point of time you require a lot of field staff as well as back-end staff to capture that information. But once your database is established, your base is ready, then less than 5 people can manage entire thing, and that is a combination of GIS engineer and web developer and Android developer.
Okay. Okay, I think yeah, we are done. Unless if I missed anything, please raise your hand just to let me know. But at this point, if there are no other questions, then I'd like to call on Arjun Thapan, Chair of Waterlinks. Thank you very much to both Sandeep and to Delph for
You,
very good
Thank
presentations, very informative presentations. And okay, there you are, Delph. And okay, Arjun, please, floor is yours.
Thank you very much. I'd really like to thank both Delph and Sandeep for excellent, very rich presentations. And I think this subject of apparent losses complements very nicely the previous seminar on real losses. So well done, both of you. I stand very educated as a consequence of what you have just discussed. Very clearly, as Delph said, the question of apparent losses falls into three components, namely illegal connections, metering inaccuracies, and data handling errors. And I think the examples that we have both from the US and from India in the two respective presentations were very compelling. I think what has been done in Clayton County and it's obviously been done in so many other places and is really where we need to go. We need to go from a random testing approach of meters to a proactive approach. And that is very clearly shown where you showed us, Delph, that only about 6 to 10% of meters were found to be replaceable as a consequence of using the random testing approach. Whereas if you use the data-driven proactive approach, you can get far higher benefits. I think the example that Sandeep gave us from what Suez is doing in India, the ropes software, that is extremely interesting, and that perhaps is the way to go in a country like India. But I think there are two issues that we really haven't discussed fully today, and perhaps we should try and come back to them in due course. One is theft. And I think theft constitutes, certainly in socio-economic environments like South Asia, constitutes a fairly significant apparent loss. And while many might argue that water stolen actually is water consumed, that's okay at one level, but the fact is that it does affect the utilities bottom line. So to not look at theft is, I think, to ignore a very real and serious problem. Of course, there are very many interrelated causes of why people steal water, including the fact that most cities in South Asia particularly, and perhaps a little less in Southeast Asia, have between 20 and 40% of their population who could be described as urban poor, and living in the kinds of slum areas that Sandeep showed in his slides. But there also is this issue of very high real losses, which is why there is never enough water to go around, which is why many people, particularly the urban poor, end up stealing water. But I think having understood that having recognized that, we really need to have the ability to digitally use technologies to measure what is being stolen. At least if we have an idea of the incidence and volume of theft, we can bring these to the notice of authorities, whether there are regulatory systems in place or whether there are local government units or municipal bodies, and it's up to them to take a decision. But certainly the utility should be looking at theft a little more squarely and using today's technology to be able to measure what is being lost through this particular cause. Delph also spoke about data handling errors, and I don't think we've discussed that. We've referred to it, and I think it also impacts on billing. And there again, you have commercial losses which are in play. But I guess this is something that we need to cover separately and not muddy the waters, so to speak, in regard to the very excellent presentations that have been made this afternoon. So once again, Sandeep and Delph, many thanks from us at Waterlinks and Xylem, and we hope to be in touch with you in the not too distant future. Thank you very much.
Thank you.